Hello and welcome to the new series of Drishti IAS. I am Pooja Dwivedi, and in this segment today we are going to talk about the approval of the world's first ever DNA vaccine, ZyCoV-D. This topic is important from the perspective of prelims and also from the perspective of GS mains paper. So let's begin. First, let's have a look on the topics of discussion. These are the topics that we are going to discuss step by step, starting with the news. So, indigenously developed, the world's first ever DNA-based vaccine has got emergency approval from Drugs Controller General of India. We will discuss all about it. But have you ever wondered how many stages a particular vaccine or a drug goes through to be getting approval for emergency use? Let's look at how do we do that. In India, if we talk about India, the approval of any drugs or vaccines are governed by three laws. These are Drugs and Cosmetics Act of 1940, Medical Councils of India Act 1956, and then Central Councils of Indian Medicine. Okay, so these are the three particular rules and laws that govern the approval of any drug or vaccine. But for vaccines and drugs, for clinical trials, some things have to be checked. The boxes of some particular criteria have to be checked. First is, if I am running an organization and I want to get my vaccine clinically trialed, what do I have to do? First, I have to get the permission from the Drugs Controller General of India, DCGI. Then I will have to get permission from the ethics committee of whichever centers I am going to have my clinical trials in. Suppose I want to get my vaccine get trialed in some institute. I will talk to the ethics committee, and once they approve, then I will register my vaccine in the maintained website of the Indian Council of Medical Research. Then I will start with the phases of the clinical trial. In the first phase, phase 1, that is first in man. This is the beginning of any clinical trial in which I will employ 1 to 2 healthy, informed individual. Informed, they will be told about the possible side effects and the effectiveness of the vaccine. Here what will I look at? I will look that the vaccine is tolerable and also behaves in a predicted way. Okay, then comes the phase 2. In phase 2, I will have the vaccine to work on 10 to 12 people from 3 to 4 centers. And what will I do? This is the exploratory stage. Okay, here I will look that it is effective in nature and also it does not have any unacceptable side effects. Then comes the phase 3. This is confirmatory, and here I will employ 1,000 to 3,000 people, informed individuals, and here I will check the effectiveness and efficiency of the vaccine. Then comes the last phase, that is phase 4. Here this is also known as post-marketing stage on a mass number of people. Okay, so these are the different stages. And if we talk about ZyCoV-D, this vaccination trial had the highest number of clinical trial subjects, 28,000, in which 1,000 were children from the age of 12 to 18 years. And this is why it is showing the large amount of efficacy, and that is why India is very confident with its DNA-based vaccine. Let's know about the ZyCoV-D. But before that, let's move on certain more procedures. First, regulatory provisions for approval of vaccines in India. It is right now governed by Drugs and Clinical Trial Rules of 2019 along with others. I will tell you about the others as well, before that also and after that also. And there is nothing such as emergency approval. It is not written there, but it is written accelerated approval process. In case such as this pandemic, any country needs to have a vaccination program for illnesses which are very serious in nature, which have a threat to the life, and which are specifically for the country's needs. Also, if these all criteria are met, then it will be accelerated. The approval will be accelerated. And if it shows meaningful therapeutic benefits, even in phase 2 of the vaccine, okay, then it will be approved. Also, remarkable effectiveness is reported from phase 2 trials we have done, and additional post-licensure studies will be needed for such vaccines because it has a limited validity right now for only 1 year. Okay, the license is only for 1 year. So it needs to be renewed. Okay, let's move forward and talk about the very important organization that has approved this vaccine, that is CDSO, Central Drug Standards Control Organization, under the Department of Health and Family Welfare. Okay, so this is governed by the Drugs and Cosmetics Act of 1940 and the 1945 rules to approve the drugs and the vaccines. Okay, so this organization is very important from the perspective of prelims. Kindly know more about it. Let's move on and talk about ZyCoV-D. So ZyCoV-D is developed by Ahmedabad-based Zydus Cadila and Department of Biotechnology under Biotechnology Industry Research Assistant Council. Okay, BIRAC basically is the implementing authority of Mission Suraksha and Suraksha for COVID. Keep that in mind. And ICMR is also involved, Indian Council Medical Research. So this is the world's first DNA vaccine against infection with SARS-CoV-2. What is DNA-based vaccine? That it employs plasmid DNA. Okay, plasmid DNA are actually employing plasmids, which are genetically engineered in the lab. Genetically engineered in the lab, along with it is non-replicating, because DNAs are replicating in nature, but here it has been genetically engineered for being non-replicating in nature. And what is this non-replicating in nature? That means it will not replicate, it will not multiply by itself. What will DNA vaccine do? We will talk about it in our next particular procedure. This is a 3-dose vaccine. Okay, 3-dose vaccine, and every dose will have a gap of 28 days. So keep that in mind. Then first, okay, so first dose, after that 28 days of gap, then for second dose, then 28 days of gap, then another dose. And here the most important feature that you need to remember is no needle is used. Needle is not used in this particular vaccine. And what will it employ? It will employ this spring powered injector for a more precise and pain-free administration of vaccines, because it has to be employed for people who are minimum 12 years of age to above. Okay, let's move on and talk about the vaccine that has been able to bring down symptomatic cases of COVID who has administered the doses, and that is to 67%. Okay, so we need to keep one thing in mind, that 2 doses of vaccine, it minimized hospitalization, and of course it has kept the symptoms moderate. And it has also been observed that if 3 doses have been administered, then even moderate symptoms were kept at bay. Then effectiveness against the Delta variant, we need to understand that approximately 50 centers were chosen during the second wave, and there we all know that 99% of the cases in the second wave is because of the Delta variant. So it has shown effectiveness against this variant. Okay, let's move forward and talk about DNA and RNA. What is DNA and RNA? Please keep one thing in mind, that SARS-CoV-2 has its genetic information in RNA. Its genetic makeup is RNA, and us humans, we have our genetic information in DNA. So what does we need to understand how does SARS-CoV-2 infect us. We do not have RNA, we have DNA. DNA is self-replicating in nature. That is why I told you in the beginning that DNA is self-replicating in nature. ZyCoV-D was genetically modified to be non-replicating in nature. So what does RNA do? RNA, that is SARS-CoV, it comes into our body, synthesizes itself or mixes itself with DNA, and then the cells will start getting infected. That is what is going to happen. Basically, any vaccination, it will have a code that will be instructed to the cells to make spike protein, which will be recognized by the immune system, so that whenever we might get infected by the same protein from the same makeup like the SARS-CoV-2, our body will have immunogenicity. Okay. So here we need to understand both the vaccines, DNA and RNA, they have the same tradition that to help the body make protein, the spike protein. This is the makeup of COVID. Okay, I am drawing these are the spike proteins. Okay, so what does spike protein do? These spike proteins will attach themselves to the cell. This is the cell. Okay, it will attach them to the cell, go inside the cell and start infecting us, and the cells will keep on replicating. So here in DNA vaccine, what happens? DNA vaccine will send a code through the messenger RNA, that is mRNA. And it will keep on pushing the messages through electric pulses, short electric pulses. And then the cells will be instructed to develop these spike proteins so that our immune system can get aware of this particular makeup of a cell, so that next time we get infected, if we may get infected, then the body will have an immunogenicity. With the RNA vaccine, we are already one step ahead of the DNA vaccine. It's like that, because here you can see DNA is converting the message into mRNA, that is messenger RNA, but RNA will be one step ahead because it already has this feature of the COVID-19 SARS-CoV virus, that it does not need to be converted, it will be more effective. This is the general theory. Okay, if we talk about DNA vaccines, there are certain pros and cons. Pro is that it is very stable at high temperature. Cons that we do not have a lot of information about the DNA vaccine right now when it comes to SARS-CoV-2, because this is the world's first DNA vaccine and there is not a lot of data which will tell us about the pros and cons of this particular vaccine. Okay, so one thing we need to understand, that it is stable at high temperature and it is better recognized because our cells have become of DNA. We have this particular procedure in our body to have DNA. Okay, our genetic information is, everything is stored in the DNA. So we need to understand that this might be more acceptable to our body. Let's move on and talk about impacts. First impact is, of course, it is going to give boost to Atmanirbhar Bharat. How? Because Atmanirbhar Bharat has 5 pillars, and here you can see demand for utilization of power and demand of supply. Here power is, if you don't read this, full utilization of power in the sense that we have our innovative capabilities and we have the demand for vaccination. That is why this innovation in field of DNA, it will be able to fulfill our demand for vaccines. And of course it will cover the early youth, because this vaccine ZyCoV-D will be able to be administered for people from 12 age to above. Okay, so a lot of youth which has been outside the vaccination net will be able to get administered, and it will also pave a way for the study for vaccination for children below the age of 12 years. Then of course it will have a better impact on the mental stress of parents who are actually very worried about their children. And as we all know that unlock phase is going on and schools are also reopening, so that will also be beneficial for the children and parents, of course, and everybody in totality. Challenges is that mass data is not available, although phase 1 clinical trial is ready to be published, phase 2 is also ready to be published, but phase 3 trials, which have been conducted on 28,000 people, it hasn't been published yet. It will take another 4 to 6 months. So that is the first problem. Second, vaccine hesitancy. Vaccine hesitancy, unless and until the community will come forward and give approval to the effectiveness and the tolerance of the vaccine, nothing can happen. Because even if we talk about the adults, we were also very hesitant at first, because this is for the first time ever when any vaccine has come for a virus, because vaccines, as I have told you time and again, for a virus to be developed, it takes a long period of time, because viruses keep on changing themselves, their makeup. So second is that. Infrastructural gap and wastage. A lot of vaccines have been wasted because they were not being administered in the given time period, and because of that mass wastage did occur. And infrastructural gap, the supply of vaccines to the last mile, this is also another challenge. Also availability. As it is a 3-dose vaccine, then of course we need to understand how do we need to manufacture this vaccine that the 3 doses demand and the necessity of it can be fulfilled in a short period of time, because the gap between them is pretty short too, 28 days each. Moving on, let's look at our way forward. First, before that I would like to tell you a data. I'm really sorry. This is the data of after effects of immunization. There have been certain instances, that is 0 to 00, although it is very minuscule, but there have been certain instances of acute ineffectiveness, or even it has caused death. One death has been acknowledged by the government according to its own AEFI report. So certainty in the cases of children, parents are very possessive of the health of their children. So how to convince them of that? If even one vaccine does not go as predicted, what will happen after that? Let's move on and talk about the way forward. First way forward is that real-time data is needed. As soon as the clinical studies, as soon as the clinical trials get ahead, we should have real-time data about it. Also, mass participation is needed, which is community-based. If a child of a family gets immunized and nothing, God forbidden, anything of that sort happens which is not acceptable, then that particular family can encourage other families to get their children immunized. Also, infrastructural development is needed. The gap should be lessened between the demand and the supply. Proper storage facilities, proper facilities for transporting the whales, those also should be kept in mind. Then ensure availability. Of course, as I discussed that the time period between each dose, the 3 doses is too less, 28 days, then of course availability should be ensured. Moving on, let's talk about this graph which shows you the current status of vaccine. So approximately 57 crore of the population has gotten immunized at least 1 dose of vaccine. Okay, so this is a way forward for India. India is doing great when it comes to achieving the unimaginable actually. Moving on, if we talk about our mains-based question, let's look at it. Discuss about India's vaccination program. What are the challenges for India in its journey ahead in terms of vaccination? So I hope you'll be able to answer it correctly and practice with the help of this segment. That's it for today. Tomorrow we shall meet again with another segment. Until then, stay updated and thank you so much for watching.